Hi everyone, in this video I'm going to go through the types of problems for the calculator portion. I do have my answer key in front of me, so for the most part I'm just going to I'm going to explain how the problem comes out and then just the calculation. So with this first one, you have an investment of $3,200 that yields a 7% annual increase. What is the interest accrued? This is an important part of the question. At the end of the 5th year, the investment was made. So since it's an annual increase, we can just use the standard equation, 1 plus r to the t power. So my initial investment is 3,200. 1 plus the interest is 0.07 to the 5th. This value gets me $4,488.17. Now, what's important to realize is that this would be the value of the investment, not the interest accrued. Interest accrued would be the difference between that value and my initial, so that would get me a total of $1,288.17. Okay, using the following scenario, answer the parts. Bank grows continuously compound interest at 0.25%. So remember, 0.25% is actually not 25%, it's 0.25%. So when I actually use the rate, I go 0.0025. So we plan on leaving $10,000 in a bank account that will grow. So y equals 10,000 continuous 0.0025 times 10. So 10,000 e to the 0.025, which gets me $10,253.15. That feels a little bit more accurate to actual bank increase rates. Now, the question if we want to double our value. Now, this is an important question just because I gave you a value to start, but we don't need a value. So, for example, in this case, it's 10,000. So that means we know, we know the ending value here. So 0.0025t. So the idea here is when I actually do my first step of dividing both sides by 10,000, as much as I want, I don't need to necessarily have given you a value. Because if I just say we want to double a value, we will always just pick a value and double it. That first step will always be 2. So this is actually unneeded at any time to actually have a starting value technically. So since this is e, we can ln both sides, which gets me 0.0025t. When I divide by 0.0025, that gets me 277.26 years. To put this into year and month, that would obviously be 277 years. And 0.25 years is roughly 4 months, we can say. From the top of a lighthouse, you can see the edge of the water at an angle of depression of 35 degrees. So here's my lighthouse. Here's my water. My angle of depression always comes from the horizontal down, that's 35. If we are 100 feet above the ground, how far is the lighthouse from the water? So here is really the diagram in terms of the triangle. And so if we just use alternate interior angles, we can see that this is also 35. So tan 35 equals 100 over x. X equals 100 over tan 35. And so when I calculate that value, I get 142.8. Looks like feet. This is in feet. The sound of a speaker varies jointly with the volume of the Spotify app playing the music and the volume of the physical speaker volume. So since it's a joint variation problem, there's going to be, 2 things being multiplied together. So I'm going to kind of write out my variables because the wording for the rest of this problem gets a little bit tough in terms of distinguishing what is what. So I'm going to say that M is the music volume. So what I'm actually hearing is M. S is the sort of Spotify volume I have on my computer. And then V, I'm going to say, is the speaker volume. So what the setting is on the speaker I'm playing Spotify through. So remember that nowadays we can control music through a speaker on a Spotify and on their speaker app. And when I control one or the other, it modifies the music volume. So M equals K times S times V. So we get 56 is K times 40 times 70, because it says when the Spotify speaker and the volume of the speaker is 70 and 40, the music volume is 56. So I have to solve for my constant. So when I divide, I get my constant is approximately 1 over 50. And so now I have this equation. And so then it says, let's say I change the speaker volume, or the Spotify volume, to 100. So the speaker volume is going to stay the same, which gives me a final of 80 decibels. Then the next one, find the average rate of change of the function cosine 2x on the interval. So remember, we have this formula. That's not the one I wanted to use. F of x2 minus f of x1 over x2 minus x1. Here's x1, here's x2. So if I plug these in, now initially I don't know cosine of 5 pi over 6. However, when I actually multiply it by the 2 in front, I get cosine of 5 pi over 3, cosine of 0. So cosine of 5 pi over 3 is right here. And so that would be the 1/2 value. So I get 1/2 minus 1 over 5 pi over 6, negative 1/2 over 5 pi over 6, negative 1/2 times 6 over 5 pi, because it's reciprocals, reduce negative 3 over 5 pi is my average rate of change here. All right, so now we have a sort of bike wheel rotation problem. So if I have a bike that's spinning at a rate of 10 revs per second, so remember it's making 10 full revolutions a second. The diameter of the wheel is 3 feet, which means its radius is 1.5 feet. What is the speed of the bike in feet per second? So we know that in 1 rev is 2 pi rads. And in 1 rad, we have that the arc of the circle is 1.5 feet. And yeah, that's everything I want. So when I do this computation, I get 30 pi feet per second. Okay, so now the next question is, how far would we travel if we had gone this speed for 30 minutes? So we basically need to take our 30 pi feet per 1 second. I need to convert that into minutes. So that's going to be 60 seconds in 1 minute. And so I get 18,000 pi per minute. And then finally, I take the 18,000 pi and multiply that by 30. And so that gets me 54,000 pi feet. So quite a distance, whatever that is going to end up being. And then the next question is using long division to actually do this division. So I don't know if I'll have enough space to do it all on here. I know on my answer key I have it on a separate paper. So let's see how far I get. X to the 4th plus 3x cubed minus 8x squared minus 12x plus 16. So again, I have to cancel the first term, so x cubed. This cancels. This becomes 6x cubed minus 8x squared minus 12x plus 16. Then this becomes plus 6x squared. And then subtract. So this would become See, I already made a mistake here. Did I make my mistake? Oh, that's a -1. Oops, sorry about that. I knew I was going to make a mistake here. That should be a -1. So this should be a 4. So this should be a 4x squared. Yeah, that's better. So 4x cubed minus 4x squared. So this becomes minus 4x squared. Yep. Minus 12x plus 16. Oof. Okay. And then this becomes a minus 4x. So this becomes minus 8x plus 16. All right. Oh, that should be a plus 4. So this becomes minus 16x. Whew. Sorry about that. It's so hard to see this. Okay, and then this becomes a minus 16 at the end here. It's a plus 16, so these all cancel out. So we get the final answer, x cubed plus 4x squared minus 4x. Sorry, I hit that by accident, minus 16. So I hope that was kind of helpful. But just remember that the process is pretty much the same once you get started. You can always check with synthetic if you wanted to. The next question is find the value of R4 over S of -4. Well, the thing is, you could do them individually, like we had done in the non-calculator section. However, this is the product of R divided by S. So I'm actually just going to plug -4 directly into here. Which gets me 0. And there's an important reason for that. So part C, based on my answer, what that means is that -4 is a root of R of x divided by S of x, from part A, which also implies that it is a root of R of x. Next question, so we have a corral that has 3 equal sections, so I'm going to call each of these sections x and each of that length y. We want to maximize the area here. So we know that the perimeter would be 2 x's, top and bottom, 1, 2, 3, 4 y's, so that's 600. The area itself is x times y. Now the thing is, in this equation, we want to maximize, but it's in 2 variables, so that's a problem. What our key is the fact that I can isolate, let's say x in this case, so 600 minus 4y equals 2x, divide everything by 2, and so I get x equals 300 minus 2y. I can replace this x with that. So I get that the area equation is 300y minus 2y squared. Let me rewrite this like that. And now I have to find the sort of maximum. Now, I know this is in terms of y, but just imagine for a second it's an x equation. If I wanted to find the maximum of something that's quadratic in nature, well, I can just use the max equation, negative b over 2a. So I'm going to do that just for the y component. So this is my b, so negative 300 over 2 times -4, or 2 times -2, which is positive 4. So negative 300 over -4, that gets me a y value of 75. So that means the y coordinate is 75. So then to get x, I just plug 75 back into my isolated equation, and I get that my x dimension has to be 150. All right, so now using laws of sines and cosines, we're going to find the area of this. Actually, I don't need the law of cosines in this problem because since we know 2 angles, I can get this to be 42, which means I can do sine of 42 over 16 equals sine of 29 over, I'm going to call that ST. And same thing, I can do sine of 42 over 16 equals sine of 109 over RS. And so I can do some cross multiplying and dividing. So ST is 11.6, RS is 22.6. So now I can actually go in and do Heron's formula. So the semi-perimeter in this case is 25.1. That's if I add up all three sides and divide it by 2. So the square root of 25.1 times the difference of each one. So this would be 25.1 minus 16. Then the next component would be 25.1 minus 11.6. And then the next one would be 25.1 minus 22.6. So I get the square root of that final value, 7,008.8, which is approximately 87.8 kilometers. All right, and then in 21, the keeper of the lighthouse spots 2 different ships at night. Ship A is north 42 degrees west of the lighthouse, and ship B is north 58 degrees. So here's my lighthouse. So here's north, east, south. I don't need to write out south because it's not going to go down there. So here's my boat. So north 42 west. So this is a 42 degree angle. Here's the other boat. North 58 east. And we know that they're going to collide exactly 2 miles from the lighthouse. So now that we actually have the diagram happening, this is 2. We know both sides here is 42 and 58, which is not a 90 degree angle, it's a 100 degree angle. But it says how far is each ship from the lighthouse. So this is X, this is Y. And what we can do is, since they're both right angles, because it's exactly 2 miles north, meaning that this is a right angle, we can actually just use cosine ratios to do this. So here's my opposite, adjacent, hypotenuse. So if I just do cosine of 42 equals 2 over x, and on the other side it would be cosine of 58 equals 2 over y. Y equals 2 over cosine of 58, x equals 2 over cosine of 42. And so I get 2.7 miles for the first ship and 3.7 miles for the second ship. Now to solve all values within that domain, so this is a factorable equation, just like if this was x squared minus 1x minus 2. So I get tan of x minus 2, tan of x plus 1. So I want when tan of x equals 2 versus when tan of x equals negative 1. Now this one is solvable within the unit circle. So that's the angle values 3 pi over 4 and 7 pi over 4. Pretty sure I have that correct. Yep. And then for this one, I have to use my calculator. I have to use the inverse button. Now remember that when I actually do this, it's only going to give me the value in quadrant 1. So that's 1.1 rads. Now, since we're asking it within the context of the unit circle, 1.1 rads is here, meaning if in tangent I rotate it exactly pi, I'll get the other answer. So this is 1.1 and 1.1 plus pi. If you wanted to do 4.23 or 4.24, that would work, but that's about it. Okay, 23. Now this one I worked out. I'm not going to work out the entirety of this problem just because of how long this is. So we have y equals x minus 3 squared x minus 5. Now remember, in its entirety, if it tells me the root, I do the opposite, and then my multiplicity tells me what degree. This one would be x minus 4 plus I and x minus 4 minus I. Now this is sort of an asterisk here because when you have this type of multiplication, that would be the term where the conjugate works for the one side and the other. It's similar to a unit circle type of a thing. Now, x minus 3 squared times x minus 5. If I want to distribute all this out, x squared minus 8x plus 17. This would be my final term here in terms of my answer. This is the only one I would actually multiply out. To put the solution in standard forms means I have to actually keep distributing. This is the calculator section, so you are allowed to double check your work with a calculator. This was quite tedious, so please don't think that you'd have to do this in its entirety without the use of a calculator. I definitely had to make sure I had all my answers correct in the calculator as well. All right, and then I think this is our last problem. So on average, we have this function here. It gives us this equation where E is the number of energy drinks and the entire equation is our score. So if you had no energy drinks, what would you expect your score to be? So that would just be that E is equal to 0 in this case. So if I do that, I just get sine of 0 basically, but sine of 0 is 0. So the whole value is 13,000 points. If I've got 2 energy drinks, so I substitute 2 in. Now, if I substitute 2 in, I get 2 pi over 4, which is just pi over 2. So that's just 1. And so that would be 13,400. And then finally, what's the possible ranges? So this is where it gets a little bit more in theory. So sine of anything has a range of +1 and -1. And if I look at it in the context of this equation, that means it doesn't matter what's actually inside. That means this value can alternate between +1 and -1. I don't know why I put them in the wrong order. So that means at a high end, I can have 13,000 plus 400. And on the lowest end, I can have 13,000 minus 400. So this is my possible ranges. I don't actually need to find when they are. That's not what the question's asking. It's just saying, what are the possibilities? And so since sine oscillates, that's that word I was saying to go back and forth, back and forth, back and forth. I basically can go up by 400 or from the beginning down by 400. And so these are my possible ranges depending on the number of energy drinks I have. All right, thanks. Hope that was helpful. See you in the next one.